everybody. I'm Dwayne. I live in Chicago. I love tech, improv, live music, karaoke, knitting, crochet. If you want to hit me up about any of that stuff, feel free to hit me up on Twitter or anywhere else on social media. I'm MC Dwayne pretty much everywhere. Uh, don't have a lot of time for this talk. I took on a bit off a whole bunch of trying to demystify a Git and then realized I had 25 minutes. So this talk is going to go pretty quick. And if you have questions, feel free to hit me up in the Discord. I'm over there. I work for a company called Git Kraken. We make legendary Git tools. We make a desktop client that you'll see on a few slides today. Git Kraken client helps people do the basics a lot, a lot better. It's a little safer, easier, and be more productive. Git Lens for VS Code. Very proud of this tool. That it's part of the family. Exposes Git authorship inside of your work in VS Code. If you're working with VS Code, it's free, open source. Download it, use it. It's amazing. And Git integration for Jira. If you're using Jira, it does just what it says on the box. It makes it a little easier to use Git with your Jira instances. But enough about that. We're here to talk about Git. So why am I talking about this session? Before we go any further, as I said, I only have 25 minutes plus Q&A. I can't teach you everything today. Git is a pretty deep subject. That's one of my favorite books in the world, by the way. But I'm happy to point you in the right direction. So my goal is really just to expose a lot of ideas for you, to put you on the right path toward learning more deeply about Git. So as Mike said, everybody uses Git. And for most people, they just type a command and it works. And the things over there on the right, most people aren't terrified by those. That's just how Git works. You clone, you add, you push, you commit. Uh, but sometimes we got to do other things like rebase, and we get to these detached head states and we hit merge conflicts and everybody panics. And I think that's because these things are a little mysterious and we don't really know what they do. And we're human beings. We fear what we don't understand, even though it's really not that dangerous or hard to understand. Though Git, in its defense, can seem like a really dark art. Um, there's a lot of weird terminology in it. If you read the release notes, commands learn to do other things. The word ish is thrown around a lot as a suffix. Commands like git rev parse, which is a powerful tool, but it picks out and massages parameters. Like, what the heck does that mean? And unless you're one of these guys, a lot of the how and why, not just these two, but that's Linus Torvald, who created the project back in 2005, and Junio, who took it over a few months after its creation and been maintaining it ever since. Gitster out there. Unless you're these two or the team that builds Git, some of it's a little mysterious. Like, why and is it doing this? How does it do what it does? Well, the good news is it's all open source. It's a prime example of open source and the community really taking a tool and making it their own. So you can look at the code. Bad news, it's mostly written in C. And I'm guessing most people watching this don't read C day in and day out. If you do, well, have at it. Um, and there are certain things in Git that are just conceptually, they work one way, but in reality, it actually works another way. But it was easier to explain it conceptually one way. There's a lot of things like that you'll run into. We'll talk about that a little bit with branching later. But at its heart, if we just step back and take a look at like what is Git? What is it actually trying to get done? It's just tracking the file system. If you understand the file system on your machine, then it's that's the basis for how Git works. Git is just a way to make a record of what happened to that directory, when those things happened, and who caused them to happen. In fact, if you wanted to build your own version of Git, all you'd really need is a way to compress the file system to take snapshots, a universal time tracking system. We have one of those. I actually had to pull up on my phone, and then my phone went to sleep. But it is 1,653,512,437 in Unix time right now. We have Unix time. It's been counting up since January 1st, 1970, and it will forever. And Git just taps into that and uses it. A pretty formulaic way to tell time across all your systems. And then you would need a way to note down what's in those compressed files and what time those things happened. That's kind of everything that's in Git. Everything else is just a way to get at those references. And one of the weird things in Git that is really hard to wrap your brain around is because Git controls how reality works to a certain extent because it can change the contents of a file system just by doing a checkout or a switch. Um, it's easy to lose track of like the point of reference. With Git though, everything is always local. And as long as you always keep that in mind, so no matter what the command is, if you're trying to merge, you're rebasing, you're pushing, pulling, wherever you're doing, just think of it. What's the point of view of Git? It's local to that specific instance of where you're at with Git. That's Oakland, California, by the way. I used to live about 5 blocks from there. Um, Gertrude Stein once said, "In Oakland, the problem is there's no there, so they built one. There's a here and a there in Oakland now." Um, so let's take a quick look at Git internals to explain a little bit what's going on under the covers. Now, to clarify, we are not looking at the actual CLI program called Git that you download and install on your machine that manages all of this stuff. I'm specifically talking today about what goes on in the Git folder, the actual mechanism that you add to a project that makes it a Git project. Uh, no time today to really dig into how Git does its thing, but it's becomes pretty evident as we dig into the Git folder. So let's take a look at the Git folder. And if you've never done this, if you've never cracked open the Git folder, highly recommend it. In fact, that's your homework assignment. Go open your Git folder and start playing around. It is really easy to get your hands wet in here and see like what's in all these files without breaking anything. Just go read them and piece it together. Uh, so head is one of those files. Head is a very small file. That is what head looks like if you open it up. It's 1 line long. Most of the time, that's what it is. There's situations where it can vary and be different shape, but that's what head is. It just says, hey, here's what is checked out right now. Here's from my point of view where here is. And it points to a reference, and that reference is main. So what does the reference head main mean? Well, that's one of those other files. It's the packed refs files. It keeps track of all of those references and that hash that it's keeping track of. Well, what is that hash? What's it referencing? Well, stepping back, and this is probably a part you've already read somewhere or seen somewhere else. This is literally off of the Git SCM website. Git creates snapshots over time. It's not taking diffs of each file. It's literally taking a full blown snapshot and compressing it down. If nothing has changed, so in version 3, A1 didn't change from B1 and B didn't change from B. So all it's going to do is reference that, hey, this didn't change, but it's still taking that full snapshot and then just pointing back to what was there before. Kind of get ahead of myself, but all those snapshots we call commits. So what's in a commit? A commit takes your working tree and compresses that down and then makes a list of who wrote it, who committed it, the commit size, a bunch of other metadata, and then throws it against a hashing algorithm to produce this long hash number. It does this all the way down. So every time it compresses something, it makes a reference to it by hashing it and storing that reference to the hash. At the very base level, all the individual files in a repository get shrunk down to blobs. So again, Git isn't tracking diffs, it's tracking the complete version. You can always go back to those. We'll get to that later. Uh, One of those things that you saw in the folder, because we're still digging this tour before we dig into these concepts a little more deeply, is this index. Index is a very special thing. This is your staging area. So whenever you git add, this is the file you're modifying. This is what the working tree works off of. If you have never opened it up, this is what it looks like in VS Code through its binary view. A lot of non-human readable stuff. There's some human readable stuff in there. You can see file names and whatnot, but these are the compressed down, algorithmically crunched, so they're easy to store versions of those files. When we actually do the commit, then it writes them. It writes them to a chain. So those Actual individual files, we refer to those as blobs. You can find this defined out there in documentation as binary large objects, which is what they are. But we reference those objects that are stored in the Git database by a 40 character checksum. So when I say hash, and I've used that term a little loosely here today, um, that hash, the SHA, uh, is what we actually write down if we're taking notes on like what's in those blobs. Oh, that's the reference to what's over actually in those objects. So that's what those commits actually come down to is these objects that you store in your objects folder inside of the Git repo, so the Git folder. So if check it out, this one starts in folder 39, and then the actual blob it's referencing in folder 39 inside of objects is C385. 39, C835, and the rest, that's referring to that commit. These are all commits. If you want to go see how Git actually stores them and looks at them, look through your object folder. It's not human readable, but that's how it works. So, like I say, it tracks the project as a chain of commits. Every time it makes its commit, it actually points back to the previous one and says, "This is my parent." Most of the time, you have one parent per commit. Though with branching and merging and various other strategies in the world, you can end up with multiple parents, uh, two, three, n number of parents. But most of the time, it just points back to that previous one. So you can build these chains up over time. You can look back at that chain at any time you want by looking at your Git log. Git log just looks inside of your logs folder and looks at the file that pertains to what you're looking at and spells it out for you in a format that we can read from the command line or from any other tool that you're using. That's what your commit log actually is that chain of commits. Nothing shocking there. How it stores those, though, is a kind of interesting format. You have a starting ref where it starts at, where the action ended at with the new ref, who made it, the email. That's what you config when you first set up Git, your name and email, Unix timestamp, UTC offset, and then the actual Git action performed. So in this case, I did a checkout to move to the main branch. But you might notice that, hey, wait a minute, these are the same beginning and ending commit numbers here. These hashes are the same. What happened there? Well, Git actually tracks every single thing you do, not just your commits. Commits are the fundamental unit of tracking that storage and accessing, and for 9 times out of 10, maybe 99 out of 100 times, that's all you're going to really need. Just look at the commit chain and do your work. However, for 30 days by default, it will hold on to everything you do. So when you change branches, if you delete something, if you create a branch and then delete it, it's still all there. Git actually tracks what's going on in there. And that's where Git Reflog comes in. If you never run Git Reflog, open your terminals and run one in your Git project. You will be slightly, well, my jaw dropped the first time I ever saw this. And this is actually where Reflog is referencing is, well, it's looking at head, like where has head been pointing? What has head been up to? What has it been doing in while I've been working in Git? And you can see, oh, yep, I it reset back to a good state here at rebased. I've been playing around with some branches to cause some merge conflicts, but it's all there. I can actually check out any of these states. Same way you can check out a branch or a commit, you can fully check out anything in your rough log. When you do, though, so if I wanted to say move back to right before I did this rebase, finish this rebase, I could just go back to here where I did that reset, and then everything's going to be in that state. However, it's going to put me in the dreaded detached head state, which a lot of people are horrified by. It shouldn't be. Detached head simply means you're pointing to a commit and not another pointer. You're not pointing at a tag. You're not pointing at a branch name. You're just pointing at a random commit somewhere on in your history, in your log. This is really a superpower. Detached head is one of the superpowers of Git. It sounds scary. It's a weird term, I'll admit, but it's something you should be using if you're like, well, how did I do that? What did I change? I committed this, but I remembered at one time I did this. Go ahead and check out from your ref log how far back you were from your current head. So in this case, if I wanted to check out head at 5, here that's what I would check out. Git check out head at curly brace 5, and it would put me back at this particular moment in time. I say 30 days because Git runs garbage collection at 30-day mark, and we're gonna get to that in a second, a little bit later today. Um, so what are branches then if in this big setup? Well, one thing I haven't really talked about is pointers, but this is one of those areas where Git his conceptually works one way and we have this picture in our heads, but in reality it works slightly different, but it's easier to think about it conceptually because, well, it's a weird concept. So immediately we think of this picture. I think everyone on earth that's ever learned anything about Git has seen this image. It's one of those famous pictures on the internet. And it's a little terrifying if you don't know what's going on. But this is a simplified version of what Git kind of does. Git is just a giant chain of commits, and those commits are just those numbers in the object store or the object directory that has these pointers attached to them that are even readable. That's what those refs are from back when we remember the pack file slide. So feature branch is actually pointing to this one, which had the parent of 6.1, which is even referenced over as a former parent. Um, this is confusing and baffling if you like think about it from purely how Git does the math of all of this and connects these things together. That's why we conceptually think of things like this. But that's all branch names are pointers to specific references along that chain. There's no like virtual real or alternate reality. There's no um, alternate dimension there. It's just a different pointer. And we step back and remember, like, oh, well, it's just pointers. At least to me, it made understanding Git and how it works internally a little bit easier to grasp. And notice on this one, I have hotfix and head. Yeah, multiple pointers can point at the same thing. This happens a lot. This actually happens quite a lot when we do things like merge and rebase. Rebase scares a lot of people, and it shouldn't. If merges don't scare you, rebase definitely shouldn't. A few things to keep in mind with that, but rebase is just a more complicated to use command from the command line. Not really that much more complicated of a subject if we remember how Git stores things is just those chains of written down objects with timestamps of what happened in what order. So this again comes from the Git website, the Git book actually. Um, with a merge, we preserve our history of chain of commits. That hey, there's this chain here simply now gets merged back in here. We have one string, but what really happened is we took this pointer, combined all that code, and now experiment and master after the merge are pointing at C5. We have multiple things pointing there. And actually, since we did that, head would also be pointing there. Multiple pointers pointing at the same commit in the chain. Rebase doesn't preserve that alternate chain of events. It simply replays the history that it recorded in order in the main timeline. Again, we're starting to talk about little conceptual pieces versus how it actually works. But it looks back at that chain of commits and says, all right, according to history, this was the state at this point. That's when it actually do a rebase. It says rewinding. That's what it's rewinding. It's literally calling back through history, like what happened in what order, and then it plays fast forwarding replays all the commits, and then you get a nice clean line where this is the actual reality that happened. And there you can start getting into states where, well, your rebased state is different than your head state, or not head state, sorry, the main state. Um, and now you do need to do a merge fast forward to actually get everything back up to the same place. Not here to go into great detail on merge and rebase. That's a whole talk unto itself on how to do it correctly. But conceptually, just remember that taking this list of commits, list of actions that were written down in one order, and replaying them from multiple sources, saying, all right, this happened, now this happened, then this happened, then this happened, then this happened. And since we're dealing with Unix time, we're talking, I forget, tenths of a second, or no, 1 second. It's rare that you'd have things conflicting at the second level. But anyway, that's merge and rebase basically do. This is directly from the Git book. Um, when to use rebase? Whenever you're going to work on something that doesn't leave your computer. Rebasing locally, I do it all the time. There's a function inside of Rebase called squash. You can squash your commits. And now instead of the 15 iterations I did locally to get the README properly, get the proper grammar in my README with all the proper punctuation, now I have one commit that is updated README with X. But I love that second line. If you follow that guideline, you'll be fine. If you don't, people will hate you and you'll be scorned by your friends and family. Go read the Git book, everybody. I'm going to say it at the end, but just go do it. You might have heard of cherry picking. Cherry picking is the exact same thing as a rebase. It's just dealing with one commit at a time. I say that with an asterisk. There's a little more nuance than that, but conceptually, again, different than how it actually works. Conceptually, that's what it is. You're simply saying, hey, this commit that lives over here, let's put it over here now and replay it in that order. And now it's part of that same official timeline. Um, last things, I'm wrapping up here. Merge conflicts are something that terrify everyone. I would encourage you to go manually fix them, at least for a little bit. There's some awesome tools on the market. Kraken Client, for instance, has an awesome a merge conflict editor that can get you out a lot of scrapes. But once you actually start fixing them by hand, it becomes a lot clearer what happened and how to prevent them in the future. And it's a lot less terrifying. When a merge conflict happens, when you try to merge something and a conflict occurs, it won't merge those things. It will leave those files as untracked or changed, modified but not staged, modified but not staged state. So that's what happened to this hello RB Ruby file here. Git is kind enough to say, hey, head where my point of reference was said it looked like this, but this thing you tried to merge, it looks like this. Which is correct? It's up. Editing this is editing any file. You just go in and say, oh no, I actually meant this one. So that's erase the head, puts that line there. That looks good. All right, now we're in a clean state. Now we're ready to add, commit, and move forward with our lives. Git is the stupid content tracker. If you type man git into terminal, that's what it tells you it is. Last two things and leave you on. Don't have time to go into great detail because I want to keep us back on schedule. But Git bisect. If you don't know Git bisect, it's awesome. It uses the concept of having from a good state in the past to a bad state that you're currently in to find out where something went wrong. You can have access to these slides, and this is a very brief explanation of it. But you say, hey, Git bisect, I want to tell you about a bad state I'm in, and I want to tell you about a good state I'm in. Help me figure out when it went bad. And at the end, you say, all right, cool, Git bisect reset, and then go about your work. And it helps you pinpoint the exact commit to track down exactly what went wrong. It's an extremely handy tool. At most, you're going to spend like 10 steps tracking, no matter how big the repo is. For smaller repos, it's about 6 or 7 steps, sometimes less. And Git work tree. Super magical power of Git is you can have multiple branches or multiple checkouts at once. By default, you can only have one. It makes sense because it's tracking one folder and one state of reality with head. But you can say, hey, I want to use other folders on my machine to store where those branches are. So if I want to work in my main branch, I can put that into a folder somewhere else on my machine called main. And then to check it out, I simply move my point of reference from my editor to that folder. I can do that for all the features I'm working in. This was been in the product for years, just not a lot of people talk about it, and I'm really happy to bring it to people's attention. Uh, but you can see what's on your tree, add things to that path, remove things from that path. Again, can't teach you how to ride a bike at a seminar. Hopefully, I can give you a little bit of encouragement to go and dig through Git internals and start figuring this stuff out. Just play with it. You really can't break Git. You can blow up a repo, but you can always reclone a repo. If you really want to dig deeply, go read the Git book. It's really entertaining. It's not that long. It's really dense, though. I will give it that, but it's full of a lot of witticisms and it's really fun. And if you really get stuck, if you're ever at a point where like, I do not know what to do, go to dangitgit.com and check out all the helpful pro tips there on how to get unstuck, including this final nuclear option. Just blow up the repo and start again. There's no shame in that. A lot of people have done do that and feel bad. Never feel bad about that. We're talking about modifying text files on a computer. You shouldn't ever feel bad about that as long as you got good intent in your heart. So I'm Dwayne, work for Git Kraken. Feel free to reach out to me about any of this stuff, and I'll see you over on the Discord.